So our next speaker today, he's a partner, co-founder, and CEO at DATAFOREST. It is Vlad. So Vlad, I see you are logging in here, so I will turn it over to you.
Hello, everyone. So, my name is Vlad, and today I want to talk a little bit about data-driven AI and go through how it may help your business, how to implement it, and get through few real-life scenarios and what does it give to product companies. So, first of all, let's discuss what overall type of AI we can use for products. First of all, of course, we have cases when AI gets a product core. You can think about this as about your virtual assistants like Alexa or Siri, augmented reality, healthcare, when you get an application that tracks your quality of sleep and gives you some recommendation. So we can think about this AI for products when AI is a service. Of course, we can use AI to make our product development faster. And it's not only quite buzzword ChatGPT and Midjourney generative AIs that, of course, allows you to speed up your content generation, test some marketing strategies, but also we can take a look on code analyzers that eliminate bugs, that make your code review faster, and overall shrinks your time to the market. And last group about what I plan to talk more today is a product improvement AI. So basically, AI that takes real data of your product that gets some insights and improve your customer satisfaction or your security or maybe overall your performance. In product improvement, we can define also three groups. And first domain is fraud detection. This all tools and all scenarios that allows you to find against bad actors, internal or external, and also allows you to avoid your system reverse engineering when you're working with, for example, credit cards or loyalty cards or with anything that customer try to figure out numbers and reuse them. Of course, we can't forget about forecasting and dynamic pricing, even though forecasting is more relevant for products that operate with physical goods and they don't want to get a situation when customer just can't buy an item because it's out of stock on warehouse. But another problem is not freeze too much money to your stocks because you don't know how long it will take for you to sell it. And for all kinds of businesses and digital and hospitality, you can think about dynamic pricing that helps you to get most from your essence, not sell it with static price, but increase it or decrease depends on market situation. Last domain is most broad. It's user experience optimization and personalization that gives you ability to understand your customer needs better, to know what you want to propose them, and quite important when. So if your product focus on home parties and you understand there's this like recurring case that maybe birthday party, maybe New Year, you definitely want to reach your client right before it, not 1 week after. And even though we can use absolutely different tasks in for our AI, we always have more or less the same implementation architecture. We always start with data layer. And here we try to augment our historical data, our transactional data, with detailed information about our customers and other internal blocks, and sometimes external blocks like whether outside or stock market that can affect to our customer behaviors. After that, we go to modeling case. And in modeling, we also start with data. We try to identify what features we have, why we usually start with hundreds of different features that are have some meaning for us. For example, number of sales per customer for last week or for last 3 months. And when we've done our data part, we start to real AI creation or machine learning creation. First, sometimes most complex task is choose what AI model, what ML model we will use here. From first glance, they're absolutely different, and of course, generative AI is quite far from clusterization or from let's say legit regressions. But in the end of the day, we can take a look absolutely different angles of how we solve this problem. So if we want to define what is good, what is bad, we can use clusterization approach, or we can use regression models and define some cutoff point to treat somebody as bad, what's quite common for all kinds of financial markets. As soon as we got to final models that we choose as our main, we probably almost immediately need to get to system productizing. Of course, we already heard about ML ops, and this is area where it's important, because if you have big model that may be good, but you continuously try to improve it without bringing it to production, or you have too long cycle to bring it to production, when you make a release, most likely it will fail, or you will have market changes that not reflected in a model, or maybe just won't be applicable. You don't have enough of data, you don't have enough of time to calculate this model, or the answers on it is so narrow that you can't use it in real life. So now I want to talk about some cases and some scenarios that we implemented during our working on AI, and I want to start with high demand product fraud. Interesting task. It's quite relevant for and digital goods and physical goods. So ticketing systems quite suffer from this, or physical goods that sell rare things. Let's imagine Nike present new limited edition of sneakers and it will be sold out in a few minutes. Always same pattern. Right after release, we have extra high spike of sales and we have extra fast shortages. It's lose-lose situation. Customers unsatisfied, resellers will get additional profits. Most likely you will get back bad feedbacks. Problem is quite complex by its nature. So first of all, you have quite spike of data. Human can't process it. You can't use simple AI technologies and statistical methods just because for statistical methods you need a lot of data. You need to wait till spike is finished. You need minutes, sometimes longer. And in real life, you usually don't have even seconds to make a decision should you complete this transaction or not. And you can't use classical machine learning here because you don't know who is bad, who is good. You just see some traffic. You need to divide it. Anomaly detection subset of AI probably will answer your questions. So on right side, you can see diagram of real scenario that eliminates probably 80% of fraud. It builds from 3 layers. So first layer is simplest one. We just try to identify who are bots and who are real human. It's more simple, especially for compute, because human beings never act linearly. They make mistakes, they press incorrect buttons, they wait too long or press sometimes extra fast. Bots are much more linear. They were computed to follow some pattern. You can identify this pattern and block it. Second block is also non-human solvable. You want to penalize users who buy too many items. Well, probably nobody needs 100 pairs of sneakers per month or per year. But what is normal user behavior? Should it be like 12 pairs of sneakers per year, or maybe 18, or maybe 20? So if you make incorrect decision based on your own experience, you may lose your big client who really in this, or you can skip few bots who will affect on your population, especially if you have only a few thousand pairs. Again, machine learning and AI is something that can solve these problems quite simple and find anomalies in behaviors and define what is outlier and what should be penalized, what should be not. And last, but quite important thing to make first 2 blocks work is to find multi-accounts. Because I mean, nothing will work if person have like 3 different accounts or 20 different accounts, and we treat them independently. It's already also brings us to anomaly detection. We can collect spatial information, we collect network information, device data from what audits were done, and using some neural networks, some anomaly detection approaches, we can define events that were too tight one to another by this multi-dimensional array and say this is the same account. And then it brings us to first 2 blocks of our algorithm. Second case, I want to take a look on related to internal threats. You can find dozens, if not hundreds of types of internal threats, but and of course you can say that you can solve it by human. So you can make a lot of checks, you can make a lot of audition, you probably can do this, but cost of this are unreasonable. For modern retail chains, it's easier to accept threat and accept fraud internal than try to fight it, too expensive. And here is where machine learning shines. So as always, you start with data. You augment this data and with information that you will require in first steps, and then you start data slicing and baseline metrics. This step is fully based on what you try to achieve. So if we're talking about theft case, let's say sales order over fulfillment, it's a type of organized crime when internal threat or internal fraud happens when salesperson add multiply items, even one item was ordered. So let's say to each pair of trousers, I will add additional pair of jackets. Then I will send it to my friend and resell it. In this case, we slice data by items. We add weight of each item. We augment it with information about each shipment and weight, and we can find anomalies. Maybe, of course, it will deviate. We can't say that this is absolutely fraud just because it's 20 or 100 grams heavy. Maybe package was wrong. But if we find anomaly in human pattern, we can look on this precisely and maybe not fully solve problem of fraud, but at least narrow area where we should check. Same thing with loyalty fraud. It's even more simpler to understand. You have multiply accounts. You understand what number of points gets to your loyalty card, what number of points transferred, what utilized, how fast they were transferred to this card. So probably nobody buy 20 items per one day in the same store. And finding these anomalies, you can absolutely easily find bad actor. Even for more sophisticated cases, like quite common for luxury goods stores that operate with cash, situation when manager register transaction only during discount period, during sales period, even though client pay full amount in cash at the beginning. It's a little bit more complex. You need to take look on this problem from different angles, from good angle and how it was transferred, from different regions of store, how it was cross-checked, and of course from manager angle to understand maybe he've done too many sales during discount period comparing to other managers, or maybe he used some long-term reservation just to show that nobody can sell this item. Main problem in this task is productizing this, because you need to finish not with some report or some logic. You always need to finish with alerting system. So it's, as previous speaker mentioned, AI is not only about AI, but about bringing it to life. And here you really need to think how you will alert, whom you will alert, how you will check this data. But again, everything is possible. And getting out of physical goods, I want to talk about customer satisfaction. We have a client, so it's chain of golf clubs in United States, and they saw next pattern: members who got quite long-term membership and who visit clubs for hundreds of times, but they are like home club or country clubs that's closest to their area. When they visit another country club from same chain, they spend them more or less the same time, but they spend 4 times less in money equivalent and 5 times less in number of consumed service. Key problem here is that when you got to new place and nobody knows you and you have absolutely another manager who treats you, they can't give you correct recommendation. And for human, it's easier not to choose if you have too many options. This task required 2 angles of AI. So first block was in customer recognition. When you have big area, you can't ask your customer to pick your card each time when they go to restaurant or when they talk with anybody of employee. So to do that, we implement computer vision, we implement device identification, because all your phones, they connect to Wi-Fi, to Bluetooth, you can identify it quite easily, and geo in-app tracking. What it brings us that when customer gets too close to anybody of crew members, they immediately see on their tablets profile of this customer and what they should recommend him. Maybe in restaurant, it should be steak, or they should propose them to go to shooting range after golf because he quite commonly uses. Maybe he don't even know that it exists in this particular club. And recommendations system that basically utilize all information about this customer across all chain, across all his previous visits, and just find what patterns he follows, what preference he have about his habits, and what products and services he utilizes fully. Of course, it doesn't bring us to same level of services as it in home country club, but it allows us to increase revenue 2.5 times for customers who visit country club first time. And just to sum everything up, of course, AI is not already buzzword. And of course, you can implement AI to almost any type of your product business. It can be real goods, it can be digital products, it can be service, hospitality, whatever. But you need always to follow next, at least from my perspective, next 3 main blocks in this. So first of all, data first. It's all good rule, garbage in, garbage out. What means that if you try to create at least data-driven AI, there is no AI that will make good results on bad data. Frankly speaking, it's similar for all ChatGPT and Midjourney. All content, for at least visual content for this presentation, was done with Midjourney, and it's not so easy to get good results from bad requests. So same here. You don't want to make AI just because everybody talks about it. You need to have clear objectives, and you need to understand what you try to solve with it. So you don't think, okay, I have AI, let's make it to our business just to make it faster. It will give us some benefits. Probably it will, but at first you need to understand what goals you follow. And last thing that I already mentioned previously is a creative approach. So don't waste a lot of time on making an ideal solution. Just make something that works, productize it, see that it really works, and then update it again, and then productize. And you will have endless cycle, but it's much easier to, first of all, fix issues during first releases. And it makes much more sense to improve something that really works instead of bringing model to production or AI to production and understand that it won't give you any kinds of benefits. Probably that's all from my side. And if you have any questions, I'll be happy to answer them during Q&A session.